This video is about finding derivatives using the quotient rule. We start off with the theorem that says if f and g are differentiable at x and g of x does not equal 0, then the derivative of the quotient f of x over g of x exists, and the derivative will be g of x times f prime of x minus f of x times g prime of x, all divided by g of x squared. So I like to have my students learn to say this. So if we say this out loud, we would say the bottom times the derivative of the top minus the top times the derivative of the bottom, all divided by the bottom squared. So we're going to take a look at examples. I've put the words up here at the top so that we can see it, and we'll say it every time that we take a derivative. And the first couple I'm going to write down every single little step. So we're going to start here with our f of x. So our f prime of x is going to be the bottom and then the derivative of the top minus the top function, x squared minus 4, times the derivative of the bottom function, all over the bottom squared. So if I now go in and I actually find these derivatives, we will have that f prime of x is x squared plus 3 times 2x minus x squared minus 4, also times 2x, divided by x squared plus 3 quantity squared. Now I'm going to simplify this, and I happen to notice that I have a 2x. So I'm going to factor that 2x out, and I'll be left with x squared plus 3 minus x squared plus 4, because we are distributing this negative sign here, all over x squared plus 3 quantity squared. And x squared minus x squared is going to add to 0. Our 3 plus 4 is going to add to 7. So we'll write the 7 here. So our final result is going to be 14x over x squared plus 3 quantity squared. Okay, so let's take a look at this next example. Here we have y, so when we take the derivative, we'll use y prime. And we're going to say it again. So this is the bottom, e to the x plus 4x. And then the derivative of the top. So the derivative of the top here is going to give us 6x minus 5. Minus the top, 3x squared minus 5x. And then the derivative of this bottom piece is e to the x plus 4, all divided by e to the x plus 4x squared. So let's try to simplify this one as well. We're going to start by distributing the black factors and the red factors on top. So that's going to give us y prime equals 6x e to the x plus 24x squared minus 5e to the x minus 20x minus, notice I'm keeping this in parentheses, 3x squared e to the x plus 12x squared minus 5 x e to the x minus 20x all over our e to the x plus 4x squared. And then I think that we can simplify this. This is 6x e to the x. When I distribute this negative, I get plus 5x e to the x. So I get 11x e to the x. How about this? Minus 20x. And then when I distribute, this becomes plus 20x, so that adds to 0. We've got plus 24x squared minus 12x squared, which is 12x squared. And then the other two are not like terms, so we have minus 5e to the x minus 3x squared e to the x all over e to the x plus 4x squared. Okay, let's take a look at this last example on this page. I do have a typo, so let's fix that first. I would not say dy dx of this function. I would only say find the derivative with respect to x of this function here. So that y should not be there. And let's again go through this process. We're going to say it. The bottom. What's the derivative of 5e to the x? 5e to the x. So this is the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Now, this often happens when we're working with an e to the x because it's its own derivative, but I notice that I have a 5e to the x in each one of these. So I'm going to factor that out and get 5x plus 3 minus 5, and then 5x plus 3 squared. And then my final result will be 5e to the x times 5x minus 2 over 5x plus 3 squared. All right. For this next example, we're going to use the derivative rules to find the derivative of p of x equals 4x cubed plus 3x plus 1 divided quantity 2x to the 5th. So we're going to start by using the quotient rule. So when we use the quotient rule, we're going to say the derivative p prime of x is the bottom, 2x to the 5th, times the derivative of the top, which is 12x squared plus 3, minus the top, 4x cubed plus 3x plus 1, times the derivative of the bottom, which is 10x to the 4th, all divided by 2x to the 5th squared. So I'm going to simplify this further by distributing through 24x to the 7th plus 6x to the 5th minus 40x to the 7th minus 30x to the 5th minus 10x to the fourth all over 4x to the 10th. Simplifying still further, we're going to collect like terms. So we've got a 24x to the 7th minus 40x to the 7th. That's going to leave me negative 16x to the 7th. 6x to the 5th minus 30x to the 5th is minus 24x to the 5th minus 10x to the 4th. And then instead of dividing the whole thing by 4x to the 10th, I'm going to divide each one by 4x to the 10th. So remember, if they have the same denominator, we could add or subtract them and it would look like all over 4x to the 10th. But by the same token, we can simplify it this way. And then when I actually do the simplification here, I'm going to get minus 4x to the minus 3 minus 6x to the minus 5, and then minus 5 halves x to the minus 6. So this would be our result, p prime of x. Now, if I had not wanted to use the quotient rule, I didn't have to. I could have simplified p of x before taking the derivative. And in order to do that, I'm going to take each one of these terms and divide by 2x to the 5th. So p of x, before I take the derivative, is going to give me 2x to the negative 2, 3 halves x to the negative 4, and 1 half x to the negative 5. And then when I take the derivative, p prime of x, I get negative 4x to the negative 3 minus 6x to the negative 5 minus 5 halves x to the negative 6, which you can see is the same result I got here. Now in this particular case, we didn't have to use the quotient rule. We could have done it the simpler way. But there are some, like the next one, that using the quotient rule is actually easier. So had I, in this particular case, multiplied out the numerator here for f of x, I would have gotten 24x e to the x. And I can really stop there because regardless of what the rest of this would have been, I would have to use the product rule here, so I may as well use the product rule in the original. So if I begin to use the product rule here, f prime of x is the bottom times the derivative of the top, which is 3x plus 1 times 8e to the x minus 4x squared, minus the top, 3x plus 1 times 8e to the x minus 4x squared, times the derivative of the bottom, which in this case is just 3, all over the bottom, 3x minus 5 squared. So I actually have not taken the derivative of this product yet. I still have to do that. We'll do that on our next step. So we have f prime of x equals 3x minus 5. And then we're going to multiply first times the derivative of the second, 8e to the x minus 8x, plus the second, 8e to the x minus 4x squared, times the derivative of the first, minus, I am going to distribute this 3, 9x plus 3 times 8e to the x minus 4x squared. So I still have to write this all over 3x minus 5 squared. Now I have choices here. I do notice that I have an 8 e to the x minus 4x squared in what would be 2 of the terms, but I don't have it in all 3. So I'm just going to take the opportunity to multiply this out. I recommend that you do so also. I will put a simplified form up, but make sure that this is. On this last example, I'd like to just set it up rather than simplifying it completely. But you'll notice that if I multiply out this in the numerator, x to the 5/3 minus 6x times x squared plus 6x, I'll just get another algebraic expression with just x's in it. So in this case, again, I have not taken the derivative yet, but I should get x to the 11/3 plus 6x to the 8/3 minus 6x cubed minus 36x squared all over 3x minus 4. So again, this is just the simplified form of y. We have not yet taken the derivative. If we take the derivative, it'll be the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. But in this particular case, multiplying out this numerator makes our lives a little bit easier. When it's all said and done, you should get 8x to the 11/3 plus 46/3 x to the 8/3 minus 36x cubed minus 36x squared minus 64x to the 5/3 plus 288x all over 3x minus 4 squared. So I recommend that you go through this process and then practice, because you have lots of fractional exponents here, but this should be your final result. That concludes this video on the quotient rule.